Let's talk about polar curves. Specifically in this video, we'll talk about the slope of the tangent line to a polar curve and also the equation of the whole line. All right, so first we have a formula for computing dy dx, so the slope of the tangent line of a polar curve. So you're given a polar curve as r equals some function of theta, and then we know the conversion between polar and Cartesian is x equals r cosine theta, y equals r sine theta. So every time we're given a curve, we take this f of theta formula and put it in each of these into the r position to get f of theta cosine, f of theta sine. And then from here, we've essentially just turned this into a parametric equation situation, with theta just representing rotation instead of time. So then from here, we can use the parametric dy dx formula, which is y's derivative of theta over x's, or you could say this as dy d theta over dx d theta. Okay, so the example we're going to do together in this video is down below here. We're going to do the slope of the tangent line to r equals a half theta squared when theta is pi, and then we'll finish it off by doing the equation of the entire line. Okay, so this formula right here, this is the f of theta for the problem. This is what's defining this spiral curve. So I'm going to say x equals r cosine theta, y equals r sine theta. So this is my f of theta cosine, f of theta sine. And then for dy dx as a function of theta, I'm going to have y prime of theta over x prime of theta using these two equations. For each of these equations, I have to use the product rule for the derivative. So for y prime on top, I'm going to have these two pieces here, this f, this g, and we'll do the product rule. F prime g plus g prime f. F prime g plus g prime f. And then on the bottom, same thing for the x equation. I'll do a product rule with 1/2 theta squared and cosine theta. F prime g plus g prime f. All right. There's not a ton of simplifying we could do. We could cancel a theta from all four of these terms if we'd like, just to make this a little bit simpler. So this guy's gone, one of those is gone. This guy's gone, one of those is gone. And so our simplified dy dx formula is sine theta plus cosine theta 1/2 theta over cosine theta minus sine theta 1/2 theta. Okay, so if I want the slope of the tangent line to this curve when theta is at the angle pi, then I'm going to plug theta equals pi in here. So what I'm doing is dy dx evaluated at theta equals pi. So I have sine of pi plus cosine of pi 1/2 pi, and so on. Okay, so sine of pi is 0. This is 0. This is 0. And cosine of pi is -1. Right, so that leaves me with -pi/2 up top. And on the bottom, just a -1. So we get pi/2 for the slope of this tangent line. So we could interpret this like this pi/2 is a dy dx. So we can interpret this as like a regular line slope. It's kind of unusual to have a line with a slope with pi in it, but this is a positive number, a little bit bigger than 1 altogether. So I know that this line will be heading upwards roughly, but not super steep. Okay, so that's the slope of the tangent line. If we want the full equation of the tangent line, we've got a little bit more to do. So this pi/2 is the slope of the line. We also need the xy point. And really all we know about this spot on the curve is its theta value. So we're going to backtrack to these two equations here to find the xy coordinates of the point, the Cartesian coordinates of the point at this theta value. And we have kind of two ways to do it. So we have x as a function of theta and y a function of theta. So we can plug in this theta value pi. Or we could separately compute the radius first and then just put that number in there, but it's very equivalent. Okay, let's do it all at once. So when theta equals pi, x is 1/2 theta squared cosine of theta. So that is pi squared over 2, and then cosine of pi is -1. Negative pi squared over 2. And then y will be 1/2 pi squared sine pi. And because sine of pi is 0, that puts me at 0. So I can say xy equals negative pi squared over 2 comma 0. And now I have the point on my line and the slope of my line. So altogether, the tangent line is y minus the y value equals slope x minus the x value.